In 1901, a group of sponge divers descended into the cold waters off a small Greek island. They expected statues, coins, ancient cargo. What they found instead was a machine, a corroded lump of bronze. Inside it were gears, dozens of them, precision cut, interlocking, designed to move together, and it was 2,000 years old. For decades, scholars refused to believe what they were seeing, because if this device was what it appeared to be, it meant the ancient world had built something we weren't supposed to discover until the Renaissance. A computer, lost beneath the sea, and history was never the same again. History tells us a comfortable story, that progress is linear, that ancient people were brilliant, but limited, that true mechanical complexity belongs to the modern world. But sometimes, the ocean disagrees. Because beneath the Mediterranean Sea, hidden inside a Roman shipwreck, lay a device so advanced that when scientists finally understood it, they had to rewrite the timeline of technology. This was not a simple calendar, not a decorative mechanism, not a curiosity. It could predict eclipses, track planetary motion, model the cosmos itself, and it was built more than 2,000 years ago. Tonight, we uncover the Antikythera Mechanism, the ancient computer that shouldn't exist. And the deeper we look inside it, the more uncomfortable the truth becomes. To understand why the Antikythera Mechanism shocked the world, you have to go back to the beginning. The year was 1900. A group of Greek sponge divers, caught in a sudden storm, sought shelter near a small rocky island between Crete and mainland Greece. Antikythera. While waiting for the seas to calm, one diver descended beneath the surface, expecting little more than coral and fish. Instead, he surfaced in terror. He claimed the seabed was covered in bodies. What he had actually discovered was a Roman shipwreck, its cargo scattered across the ocean floor. Bronze statues, marble sculptures, amphorae, a treasure trove of the ancient world. But among the statues, among the broken artifacts, there was something else. A lump of corroded bronze. At first glance, it looked insignificant, just another damaged object. It was taken to the National Archaeological Museum in Athens, catalogued, and largely ignored. For months. Then something extraordinary happened. As the bronze fragment dried and cracked, gears became visible. Interlocking cogs. Delicate mechanical components embedded inside what should have been a simple decorative artifact. Except no one believed ancient Greeks built gear-driven machines like that. Mechanical complexity, especially with interlocking precision gears, was thought to belong to medieval Europe. Renaissance engineering, not the Hellenistic world. Yet here it was. X-rays taken in the 20th century revealed something even more astonishing. Not one gear, not two, but dozens. At least 30 interlocking bronze gears, arranged in layered configurations. This was not decorative. It was mathematical. And the dating was clear. The shipwreck itself likely sank around 60 to 70 BCE, which meant the mechanism had to be older. Much older. That places it squarely in the Hellenistic period, the era after Alexander the Great, when Greek science flourished across the Mediterranean. An era of mathematicians like Archimedes, astronomers like Hipparchus. But even then, nothing this complex was supposed to exist. The more researchers examined the fragments, the clearer it became. This device was built to calculate. It had dials. It had inscriptions referencing celestial cycles. It had a complexity not seen again in Europe for over 1,000 years. And that is the real shock. It wasn't just advanced. It was alone. No other surviving device from antiquity matches its precision. No workshop manuals describe its construction. No surviving duplicates confirm its production scale. It appears in history, fully formed, and then disappears, which raises the central question of this entire story. If the ancient world could build something like this, what else did it know? And why didn't that knowledge survive? For decades after its discovery, the Antikythera Mechanism sat in museum storage, misunderstood. Early archaeologists classified it as an astrolabe, or a simple navigational instrument. The idea that ancient Greeks had constructed a complex gear-driven calculator seemed too radical. It didn't fit the narrative. In the early 20th century, mechanical precision was associated with the medieval Islamic world and later European clockmakers. The prevailing assumption was simple. Ancient equals brilliant philosophy. Medieval equals mechanical innovation. Modern equals scientific revolution. The Antikythera Mechanism disrupted that clean timeline. But here's the problem. The fragments were heavily corroded. Over 2 millennia underwater had fused bronze plates together into hardened masses. The internal structure was hidden. So for decades, it remained a curiosity. Then in the 1950s, physicist Derek J. de Solla Price took a serious interest in the device. Price wasn't content with superficial classification. He suspected something deeper. Using X-ray imaging, primitive by today's standards, he began mapping the internal gear structure. What he found was astonishing. This wasn't a simple instrument. It was a system of differential gearing, technology not believed to exist until much later in history. Differential gears allow 2 inputs to create a complex output. In modern terms, they are found in automobile transmissions. And here was an ancient bronze device, using similar principles. Price proposed that the mechanism was an astronomical calculator, capable of predicting celestial events using mathematical cycles known in Hellenistic astronomy. His conclusions were controversial. Some scholars resisted, not because the evidence was weak, but because the implications were enormous. If Price was correct, it meant that ancient Greek engineers had mastered precision gear cutting at a level unmatched until medieval clockmaking. And it meant that technological regression had occurred. That is the true conflict. Not war, not empire, but historical discontinuity. Because the Antikythera Mechanism suggests something uncomfortable. Human progress is not linear. Knowledge can peak and then collapse. By the early 2000s, a new research team, the Antikythera Mechanism Research Project, used advanced 3D X-ray tomography and surface imaging to digitally unwrap the corroded fragments. The results were even more dramatic than Price imagined. Inscriptions emerged, text carved into the bronze plates, explanatory labels, instructions, calendrical markings. The mechanism was not just tracking the sun and moon. It modeled complex cycles. The Metonic cycle, 19-year lunar solar calendar. The Saros cycle, predicting eclipses. Planetary motion according to Greek astronomical models. It was a mechanical model of the cosmos. A portable universe, built around 100 BCE, which means somewhere in the Hellenistic world. Perhaps Rhodes, perhaps Alexandria. There existed workshops capable of building gear trains with mathematical precision. And yet, no other surviving machine from that era approaches its complexity. So here is the conflict trigger that changes everything. Either this device was a one-of-a-kind anomaly, or it was the last survivor of a technological tradition that history forgot. To grasp how extraordinary the Antikythera Mechanism truly is, we have to open it. Not physically, digitally. Modern X-ray tomography allowed researchers to peer inside the corroded bronze without damaging it. What they uncovered looked less like an ancient relic and more like the interior of a clock. Layered gear trains, interlocking cogs of varying diameters, pin and slot mechanisms designed to produce irregular motion, mimicking the variable speed of the moon in its orbit. That detail alone is staggering. The moon does not move at a constant speed across the sky. Its orbit is elliptical. To simulate that irregularity mechanically requires mathematical insight and technical precision. The mechanism did exactly that. It used a clever gear system to model lunar anomaly, a concept described by the astronomer Hipparchus in the 2nd century BC, which means whoever built this machine was not merely an artisan. They were applying advanced astronomical theory. And here's where it becomes even more uncomfortable. The gear teeth were triangular and carefully cut, around 1 to 2 millimeters in size. They were uniform enough to mesh cleanly. This is precision metalworking, not decorative engraving, not rough functional gearing. Precision. And precision implies tools, specialized workshops, skilled craftsmen, a knowledge base. It implies replication, because technologies that complex do not emerge fully formed from a single experiment, which leads to a quiet but powerful implication. There were likely more. Other machines, other workshops, other devices modeling the heavens. But if they existed, were they? No other surviving Hellenistic gear-driven device has been found at this scale of sophistication, which suggests either extreme rarity or catastrophic loss. And if it is loss, what happened? The front of the mechanism featured a large circular dial. Around it were zodiac markings, the familiar constellations of Greek astronomy. Beneath that, an Egyptian calendar scale divided the year into 365 days. A hand crank on the side would have turned the gear system. With each rotation, the sun advanced along the zodiac. The moon moved with it, but not perfectly in sync, because the moon's motion was mechanically adjusted to reflect its real astronomical irregularities. Now pause for a moment. This device did not simply count days. It modeled predictive astronomy. It could forecast lunar eclipses, not vaguely, but with specific timing based on the Saros cycle, a roughly 18-year period known to Babylonian astronomers and adopted by Greek science. On the back of the mechanism were spiral dials. One represented the Metonic cycle, 19 years aligning lunar months with the solar year. Another represented the Saros cycle, and inscriptions next to eclipse markers described the nature of the event, whether it would be partial or total. In other words, this was not just a calculator. It was a forecasting engine. It could simulate the sky years into the future. And this level of astronomical modeling suggests something else. The builder was deeply connected to Hellenistic scientific tradition, perhaps even to the intellectual circles of Rhodes, where advanced astronomy flourished under figures like Hipparchus. Some scholars speculate that Archimedes himself may have inspired similar mechanisms, though no direct evidence confirms his involvement. Cicero, writing in the 1st century BCE, described a device built by Archimedes that modeled the motions of the heavens. A mechanical planetarium. If that account is accurate, then the Antikythera mechanism may not have been unique. It may have belonged to a lineage. But if that lineage existed, it vanished. Now we reach the deeper mystery. If the Antikythera mechanism was not unique, why did the tradition die? The Hellenistic world was a powerhouse of science. After Alexander the Great's conquests, Greek knowledge spread across Egypt, the Near East, and Asia Minor. Alexandria housed the greatest library in the ancient world. Mathematicians like Euclid formalized geometry. Engineers like Ctesibius developed water clocks and pneumatic devices. Archimedes, in the 3rd century BCE, pushed mechanical reasoning to extraordinary heights. The intellectual infrastructure existed. So why does the Antikythera mechanism feel like a technological peak that never expanded? One answer lies in economics. Precision gearing is labor-intensive. It requires time, skill, and expensive bronze. These devices were not mass-produced consumer goods. They were elite instruments, perhaps commissioned by wealthy patrons, perhaps used for education or demonstration, perhaps displayed as intellectual prestige objects. If so, production may have been limited, but even limited production leaves traces. Workshops, manuals, fragments. And that is what makes the disappearance unsettling. The Roman conquest of the Hellenistic kingdoms gradually absorbed Greek scientific culture into a different political system. Rome valued engineering, roads, aqueducts, siege weapons, but theoretical astronomy did not hold the same cultural centrality as it did in Greek scholarly circles. Gradually, institutional support shifted. Libraries were lost to war, neglect, or fire. Knowledge transmission became fragmented. And then, as the Western Roman Empire declined, Europe entered centuries where large-scale mechanical precision was rare. It was not ignorance. It was decentralization. Without stable institutions supporting advanced craftsmanship and mathematical modeling, specialized technologies can fade. The Antikythera mechanism may represent not an anomaly, but the final surviving artifact of a fragile ecosystem of knowledge. And once that ecosystem collapsed, so did the machines. For more than a century after its discovery, The Antikythera Mechanism was treated as an outlier, an impressive curiosity, a mechanical marvel, but still isolated. Then modern imaging changed everything. In the early 2000s, a multidisciplinary team using high-resolution X-ray computed tomography began digitally reconstructing the fragments in unprecedented detail. They didn't just see gears. They saw text. Thousands of Greek characters, instructional inscriptions etched directly onto the bronze plates. This was not a mystery object without explanation. It came with a manual. The inscriptions described astronomical cycles. They labeled dials. They referenced eclipse predictions. They even included instructions on how to read the device. And here is the twist that reshaped scholarly understanding. The Antikythera Mechanism was not a primitive prototype. It was mature technology. Its design shows refinement, optimization, a system that had already evolved beyond experimentation. This suggests earlier versions must have existed. Prototypes, improvements, iterations, but none survive, which means we are not looking at the birth of ancient computing. We are looking at its last echo. And here is where the turning point becomes philosophical. For generations, history was told as a steady climb, from primitive tools to modern machines. The Antikythera Mechanism reveals something different. Technological high point in antiquity, followed by regression. Mechanical complexity at this level does not reappear in Europe until the 14th century with astronomical clocks. That is a gap of over 1,000 years. And that gap forces a difficult realization. Civilizations can forget, not because humans lose intelligence, but because systems collapse. Workshops close, libraries burn, trade routes shift, patronage disappears. Knowledge requires infrastructure. Remove the infrastructure, and even brilliant ideas vanish. The Antikythera Mechanism is not just an ancient computer. It is proof that progress can stall, even reverse. And that realization unsettles our assumptions about inevitability. Because if ancient engineers could model the cosmos with bronze gears, what else did the ancient world achieve that we have yet to rediscover? At the height of its function, the Antikythera Mechanism was not merely tracking time. It was simulating the universe. Turn the crank once, and days would pass. Turn it further, and months unfolded. Keep turning, and years advanced. On the front dial, the sun moved through the zodiac. The moon followed, its phase shifting from new to crescent to full. But hidden inside the casing, a sophisticated gear train adjusted the moon's speed to reflect its elliptical orbit. That adjustment is astonishing, because it reflects mathematical modeling derived from Hipparchus, one of the greatest astronomers of antiquity. This was theoretical science transformed into mechanical reality. On the back, spiral dials tracked long astronomical cycles. One dial mapped the Metonic cycle, synchronizing lunar months with solar years over 19 years. Another tracked the Saros cycle, predicting eclipses every 18 years, 11 days. Markers indicated when eclipses would occur. Inscriptions described their characteristics. In practical terms, an owner of this device could anticipate celestial events decades in advance. In a world where eclipses were often interpreted as omens, that knowledge was power. But the climax of this story is not simply technical brilliance. It is the realization of what this device represents. It represents accumulated intellectual capital, generations of astronomical observation, mathematical abstraction, precision metalworking, and integration into a single portable machine. This is systems engineering. And systems engineering requires culture, education, continuity. The Antikythera Mechanism was not built in isolation. It was born from a civilization that valued inquiry into the cosmos. But when that civilization transformed under Roman rule, and later fragmented, the chain of transmission weakened. By the time mechanical clocks appear in medieval Europe, the continuity is gone. The rediscovery begins almost from scratch. That 1,000-year silence is the real climax, because it forces us to confront something deeply uncomfortable. Human capability did not steadily increase. It fluctuated, peaks and valleys, innovation, and forgetting. The Antikythera Mechanism stands at one of those peaks, a bronze testament to what ancient minds achieved, and a warning about how easily such achievements can disappear. When the Antikythera Mechanism was fully analyzed in the early 21st century, historians faced a quiet reckoning. Textbooks had to adjust. The narrative that placed complex gear-driven machinery firmly in medieval Europe was no longer sustainable. The mechanism proved that by at least 100 BC, Greek engineers had mastered precision gear cutting, layered mechanical systems, mathematical modeling through hardware. In effect, they had created analog computing. And that word matters, because computing is not limited to silicon chips and electricity. A computer is any device that processes input through defined rules to produce predictive output. The Antikythera Mechanism did exactly that. Input, rotation of a crank. Rules, astronomical cycles encoded in gear ratios. Output, predicted positions of celestial bodies and eclipses. It was mechanical code, written in bronze. But its impact goes beyond technological correction. It reshapes how we see ancient civilization. The Hellenistic world was not just philosophical and artistic. It was experimental, mechanical, quantitative, which raises another question. If such sophistication existed in astronomy, what about other fields? Were there lost mechanical instruments for navigation, for surveying, for engineering? We know ancient engineers built complex automata, water-powered statues, pneumatic devices, mechanical theaters described by Hero of Alexandria. We know Archimedes built intricate war machines. But few physical examples survive. Because bronze was valuable, metal was recycled, and fragile systems decay quickly without preservation. The Antikythera Mechanism survived by accident. It sank. It was sealed underwater. It escaped recycling. Its survival was chance, which means our understanding of technological history may depend less on what existed and more on what happened to survive. That realization humbles modern certainty, because what we consider first may simply be what endured. The mechanism does not prove that ancient people were alien geniuses. It proves something more powerful. Given institutional stability, patronage, and intellectual culture, human ingenuity flourishes. Remove those pillars, and brilliance can fade. The Antikythera Mechanism is not just a lost computer. It is a mirror, reflecting both the heights of human creativity and the fragility of its transmission. Today, the Antikythera Mechanism sits behind glass, silent, fragmented, yet more powerful than ever, because modern technology, CT scans, 3D modeling, digital reconstruction, has allowed us to read what time tried to erase. Researchers now believe the device originally contained over 30 bronze gears, housed in a wooden case about the size of a shoebox. It had front and back panels covered in inscriptions, effectively a user manual engraved into metal. In 2021, new reconstructions proposed a complete planetary display on the front dial, potentially modeling Mercury, Venus, Mars, Jupiter, and Saturn according to Greek geometric astronomy. Accurate. This was not just a lunar calculator. It was a mechanical planetarium, a portable cosmos. And this brings us to the modern realization. The Antikythera Mechanism was not ahead of its time. It was perfectly of its time. It belonged to a civilization at the height of Hellenistic scientific synthesis, blending Babylonian astronomical data, Greek mathematics, and engineering craftsmanship. What feels impossible to us is only impossible because we underestimated them. But the deeper lesson is not about ancient genius. It is about continuity. Modern science thrives on publication, replication, and open exchange. Hellenistic science, while vibrant, depended heavily on patronage centers, cities like Alexandria and Rhodes. When those centers declined, knowledge transmission fractured. The Antikythera Mechanism may represent the pinnacle of an ecosystem that did not survive political transformation, which forces us to confront something modern. Technological advancement is not guaranteed. It requires stable institutions, education systems, archival preservation, and open dissemination. Without those, even a civilization capable of modeling the cosmos in bronze can be forgotten. The Antikythera Mechanism should not exist, and yet it does. A bronze machine that predicted eclipses, modeled planetary motion, encoded astronomical theory into gears, built over 2,000 years ago, lost beneath the sea, and forgotten for centuries. If this story changed how you see the ancient world, if it challenged the idea that progress is inevitable, then make sure you're part of this journey. Because history is not just about what we discovered, it's about what we forgot. Next time, we'll uncover another moment where ancient innovation shattered modern assumptions. A weapon that burned on water, a secret formula that saved an empire, and a mystery that still refuses to die. Because sometimes, the past is more advanced than we dare to admit. For nearly 2,000 years, it lay in silence. Bronze gears fused by saltwater, wooden casing dissolved, inscriptions buried beneath corrosion. The universe it once simulated continued turning above the sea. The sun rose, the moon shifted, eclipses came and went, and no one remembered that a machine had once predicted them. The Antikythera Mechanism is not just an ancient computer. It is proof that brilliance can be forgotten, that knowledge can sink, that history is not a straight line, but a landscape of peaks and disappearances. Somewhere in the ancient Mediterranean, a craftsman cut those gears by hand. He understood ratios, cycles, cosmic rhythm. He turned mathematics into motion, and then his world changed. Empires shifted, libraries vanished, workshops closed. But by accident, by storm, by shipwreck, by salt and time, one machine survived. Not to dominate the world, but to remind it. The past was not primitive. It was powerful, and we are still rediscovering it.